Section 3.7 is really about distance and midpoint of circles. So this is a little bit of a break from what we've been talking about with functions, but it's sort of in the same realm because we do have circular graphs. And what we're talking about here is a formula that you're going to need to memorize. It is the distance formula. It says that to find the distance between 2 points, the distance would be between two pairs of points exactly. And this could be like the midpoint of a circle. If you had this distance being the diameter of the circle, then what you would do is put the x coordinates and subtract them, the y coordinates and subtract them. You would square those, add them together, and then take the principal square root. And when I say the principal square root, I mean the positive square root, because distance is, of course, not going to be negative. You're always going to have a positive answer. So let's look at this. There's only one thing I want to point out to you that's a little tricky or might mess you up. Notice that this is x from point 1, and this is x from point 2 and y from point 2. This is the other one, the x from point 1 and y from point 1. In other words, these have to be in specific places. It doesn't matter which point we label 1 and 2. What matters is that we begin with the coordinates from the same point and we subtract the coordinates from the other point. So our formula would look like this. I'm going to say distance equals, and if I put the radical sign down, what it's going to have is two coordinates that are subtracted and then squared, plus two more coordinates, the y coordinates, that are subtracted and squared. So remember, when you have a negative as one of the coordinates, you're going to have to adjust accordingly, okay? So let's start with the first one. We're going to label one of these points, point 1 and 1.2, and I'm just going to do it sort of backwards here for the sake of showing you that it can be done. I'll call this one point 1 and this one point 2, and I'll follow my formula. It says start with x of point 2, which x of point 2 would be 1. And then it says subtract x from point 1. Well, this is x from point 1, so I'm going to be subtracting a negative 6. Now, when I subtract a negative 6, in effect, I add 6. So you can go ahead and change that. Next, I'm going to do the same thing with y. I'm going to start, but remember, I have to start with the exact same coordinate. I started with point number 2, didn't I? This one right here. This was my first one. So that y coordinate has to come from the same point that I started my x coordinates from. So there's from point number 2, and then I'll subtract the y from point 1, so I'll have 2 minus 7. The only thing you really might get messed up with, you can't mix and match these coordinates. The first one has to come from one point, and the second ones have to come from the other point. So now let's go ahead and finish it. I've got the square root of 7 squared plus, and it's going to be a negative 5 squared. Now, when we square things, of course, the negative, it dismisses the negative, so to speak. So we will just have distance. And what I've got here is the square root of 49 plus 25, because a negative times a negative is a positive, and I will have the distance of this one being the square root of 74. We'll just leave it like that. You would simplify it if you could. Okay, let's do the next one. Just to make things different, we'll make this 1.1 and this 1.2. I'm going to come down here and I'm going to say my formula is going to be distance is equal to, and I'll go ahead and put the formula in just so you can see where I'm filling things in from. All right, now I want the x's, and I'm going to go ahead and say this is going to be I'm going to say this is going to be the way I usually fill it in is the x and y from the same point. These are going to come from point number 2. Just keep it in mind. This is the thing I see people mess up all the time. So the x value from point number 2 is going to be a 9. The x value from point number 1 is going to be a negative 3. Whoops, this one should have said 1. And there's going to be a negative 3. Nope, sorry, should have said number 2 anyway. This is going to be the negative 3. Here's my x value, and I'm going to say minus 3 minus a negative 3, which is going to be, of course, plus a 3. Now let's do the y's. Y from point number 2 is going to be my 5. And then I'll subtract the y from point number 1, which is going to be 4. That was a lot easier. So I'm going to be doing the square root of 9 plus 3 squared, which is 12 squared, plus 5 minus 4 squared, which is 1 squared. So this is going to equal the square root of 144 plus 1, or the square root of 145, and at this point we'll leave it like that. One more. Pick your point. 1 point for 1, 1 point for 2. I'm going to choose these two. You go ahead and finish it and then come back and check. Okay, hopefully, if you're working with the same points I'm working with, you're going to say the x values, I'm going to subtract my x values from point number 2 is going to be an x of 2. From point number 1 is a negative 3. When I put the negative 3 in, I just change it to positive. The y value from point number 1 is a negative 5. The y value from point 2, from point 1 is a negative 3. So I've changed those to positives. I'll do the math. And this ends up being 5 squared. And this is going to be a negative 2 squared. And now my distance is going to be the square root of 25 plus 4, which would of course be the square root of 29. Now let's talk about midpoint formulas, and this is also dealing with circles. Go ahead and change. If your handout hasn't been updated, this should say 3.7 at the top and not 2.8. But the midpoint formula is sort of interesting. It takes the x coordinates, adds them together from 2 points of a segment, 2 endpoints of a segment, takes my x coordinates, adds them together, divides by 2, takes the y coordinates, adds those together, divides by 2. So it takes the average of the x's, the average of the y's, and it comes up with a new point that is the middle of the segment. So we have this segment graphed over here for us, and you can see that it has one of its endpoints is 6, 8, and the other one is 10, 2, and we want the midpoint of this segment. So what we're going to do is use our formula, come over here, and I'm going to say I have 2 coordinates in my formula. And what I basically do is I add the x's together. And at this point, for this particular formula, it really doesn't matter which one you start with, or if you mix them up, it won't hurt anything because you're not subtracting, you're just adding. So I'm going to say I've got 6 plus 10 divided by 2. That's going to give me my x coordinates added together and averaged. And I'll do my y's next. I'll say 8 plus 2 divided by 2. And what I, of course, have then is going to be 16 divided by 2. And then I have 10 divided by 2. And you always simplify these, of course. This would be 8, and this would be 5. And there's my midpoint. So let's see where that is. I'll take a different color pen. I'm going to go over here to 8, and then I'll go up 5. And that looks like this point right here is the midpoint of my line segment. Let's do another one. Now this one you're going to need to regraph because the graph that I've got for you, if this one hasn't been corrected in your handouts, that's not the segment we're dealing with. Let's find it. It's negative 4, negative 6. So I go negative 4 and then I go down 6, and there's my first point. And then I want to go 4, negative 6. So I go positive 4 and down 6. Here's my second point, and I'll draw a line. This is the segment that we have the 2 endpoints for. So quickly, you should be able to do this very quickly. Go ahead and find the midpoint of this line. I'm going to add my x coordinates together and divide by 2. I'm going to add my y coordinates together and divide by 2. So what I have here is 0 divided by 2. And for the second one, I have a negative 12 divided by 2. Well, it's okay to divide 0 by a number. All you end up with is 0. It's not okay to divide by 0, but it is okay to do this. And then when I say negative 12 divided by 2, I end up with negative 6. So the point that I think is my midpoint should be 0, negative 6. Let's find it. If I go nowhere on the x-axis, but I go down negative 6, this would be 0, negative 6. And it does look like it's my midpoint of that segment. Now, when we're dealing with circles, there are a couple of formats that you need to remember for circular equations. And the first one we're going to talk about is the standard form. And this is the standard form of a circle's equation. Keep in mind that the radius of a circle is from the center of the circle to any edge. That's the radius, halfway across, basically. Diameter is all the way straight through the center of the circle. That would be the diameter of a circle. And if we're setting the standard form of equation of a circle, then this is the format it must take. It'll have the variable x, and it'll say minus, and this is the x coordinate of the center of the circle. And then there'll be square that, plus y minus the center coordinate of the y coordinate of the center of the circle, and it'll be equal to the radius squared. So what I'm trying to tell you is that h comma k is equal to the center of the circle. R is equal to the radius. And this is the format when they say standard form of the equation of a circle. This is the format that you're going to need to put it in. So we're going to write the standard form if we have a center at negative 2, 13, and a radius of 8. It's pretty simple. Let's just fill in what we know from the formula real quick. I have x minus something, minus h squared, plus, and I have y minus, and it'll be k squared, and that's going to equal the radius squared. So let me put the numbers in that I know. The x-coordinate is negative 2. So I'm going to be saying x minus a negative 2. And the y-coordinate for the center is 13. So I'll be saying y minus 13. Radius, of course, is 8. So I'll be saying 8 squared. Now let's go ahead and simplify this. This, of course, is x plus 2 squared plus y minus 13 squared, and that's equal to 64. That would be my standard form of the equation of that circle. Let's do a second one. Centered at 3, 6. Well, this is h, and this is k. Radius, square root of 7. There's my radius. So I'm going to say my formula says, remember there's subtraction in the formula, so you have to watch if you have negatives in any of your coordinates. But this is x minus, and the x-coordinate is 3 squared, plus y minus the y-coordinate, or k, which is 6, and I square that, and it's equal to the square root of 7, and I'm just going to put it in parentheses to show that I'm squaring the square root of 7. So, really, I don't have to do too much to this one. X minus 3 squared plus y minus 6 squared. But I should fix this radius. When I square the square root, I actually just get rid of the radicals. So it's equal to 7. Now we're going to just use what we know a little bit to do some graphing and to pick out some points or some facts about our circle. We want the center, the radius, the domain, and the range is what they've asked us for. This is the standard form of the circle. You can see it written here. So what I really have, and I'll write it up here just one time for us, is x minus h squared plus, and I have y minus k squared, and that's equal to the radius squared. So I can pick out these different points. I can say, what is the center of my circle? Well, the center of my circle is going to be, the x-coordinate is going to be 6. The y-coordinate is going to be 5. Now, the minus was in the formula. It was in the formula, so I've got the positive value is what I want for those centers. Now, if this had turned into a plus, I would, of course, had to say I had a negative as my coordinate there. So just keep that in mind. The radius, of course, is going to be the square root of 16, which is 4. And now I want the domain and range. The easiest way to do this one is to graph my circle and look at what it looks like. Well, it centers at 6, 5. So I'll come over here and go 6, 5. There's the center of the circle. It has a radius of 4, so it's going to reach out on all sides. I'll go 1, 2, 3, 4 this way, and I'll go 4 this way, and I'll go 1, 2, 3, 4 this way, and 1, 2, 3, 4 this way. And then you can, if you're adventuresome enough, try to draw a circle. You don't have to do anything perfect here because we've already touched on the range and the domain when we drew the points. So what is my domain? Well, it's going to be from right here, which is going to be a positive 2, isn't it? And it'll go all the way over to this point, which was positive 10. For the range, the smallest it'll ever be is 1. And the biggest it's ever going to get to be is going to be 9. Easy to do once I've graphed it. Let's look at another one that maybe has a little bit different format to it. It is in our standard form equation of the circle, but the first one looks obvious to us. It's x minus h, and that's squared. But then it's plus, and there's only y squared. You have to keep in mind that that is y minus 0, isn't it? If it's just y squared, the 0 would disappear. So we will say that's y minus 0, and then that is equal to r squared. So I'm going to say this k is actually going to be 0, and I've just kind of filled it in for us there. So what is the center of my circle? Well, the center of it is going to be a positive 5, and the y-coordinate is 0 because there was nothing there. The radius, of course, is going to be the square root of 16 again, which is 4. And then I should be able to graph this one and see quickly what my range and domain are. The center of my circle at 5, 0 comes out to be right here. And I have a radius of 4, so I'm 1, 2, 3, I'll go that far to the right. I'll go 1, 2, 3, 4 this far to the left. How far down do I go? 1, 2, 3, 4 down, and 1, 2, 3, 4 up. And then I can fill in the circle if I want to. But those markings are enough to tell me the range and domain. So, what is the domain? It starts over here at 1. And it goes as far as 9. The range goes down as far as negative 4 and up as far as positive 4. Now I want to add something to this page because we're about to be talking about a different format on the next page. We're going to talk about the general form of the equation of circle instead of the standard form. And I want you to see, just real quick with the equation, the first one that we worked with on this page, number 1, I took that particular standard form of the equation and wrote it down. And as you can tell, we could do some foiling and we could change this into a different format. That's how it would be done to take it from standard to general form. In other words, you just do the expanded math. Let's go ahead and see if we can do this, and I'll show you what happens. I'm going to say x times x here is x squared. And then I say, multiply these two together, I get negative 6x times 2, that's negative 12x. I square the second one, that's going to be a positive 36. And then I'll do the same thing to this binomial that's squared. It'll be y squared, and it'll be minus 10y, and it'll be plus 25. And all of that is equal to 16. Now, I want to get this in a certain order to have the general form. It also needs to be equal to 0. So when I say it's equal to 0, I'm going to be subtracting 16 from these numbers over here. So I'll go ahead and put that down. And then I need to add these terms together that I've got. So the first one, let me just draw a line so you can see what I've done. First one is going to be the x terms. X squared is going to come first. So I've got the x squared term. The second term in the general form is the y squared term. So I've got x squared plus y squared. The next thing I want is the x variables. Well, I have negative 10x, and there are no more, so I'm going to write that down. And the next term I have is the y variables, and I have negative 10y. That's a negative 12x, negative 10y. And then the last thing I want is the constants. So I have, because this is going to equal 0 over here, I've already taken care of these two. I'm going to be saying 25, and then I'm going to be adding 36, and then I'm going to be subtracting 16 to get the constant variable, and it comes out to be positive 45. That is my general form of the same equation for a circle. Just keep it in mind. X squared plus the y squared plus the x term minus the y term, and that's going to be plus the constant, and it's set equal to 0. Now that we've done that math, it might be a little easier to understand what we're talking about when we look at this general form of the equation of a circle, which is laid out just like we did our equation on the previous page. The problem here is they've asked for center, radius, domain, and range again, and we cannot tell that from the general form of the equation of the circle. We've got to get it back to standard form. And to do that, we have to rearrange these coordinates, or these different terms, and then we're going to have to do something called completing the square and see if we can figure out what the radius is and what the different coordinates are. So let's work on this particular equation here. What I'm going to do first is I'm going to line up my x's and my y's, and I'm going to set my constant 20 over on the other side. So I'm going to send this constant to the other side as a negative 20. And then I'm going to put the x's and y's together. Okay, here's my format. I'm going to say x squared minus 12x, and I'll group those together just to show that's necessary in what I'm doing. And then I'm going to add to that my y's, which is going to be the y squared plus 6y. And what's it going to equal? Well, I got rid of this 20 on this side. It's going to equal a negative 20. So take a look and see if you can understand what we've done here. We have just created two possible perfect square trinomials. If I complete the square on this one and complete the square on this one, then I can take the square roots. I can come up with the factor, the perfect square trinomial factors, the binomial squared, and I'll be able to tell what my center is. And that's the whole job here. So how would I complete the square for this particular binomial, x squared minus 12x? Well, what I would do is take half of this negative 12, and then I would basically take half of this negative 12. I take negative 12 divided by 2, so I'm going to get a negative 6, and then I would square it. So let's do that. I'm going to say x squared minus 12x, and I'll say negative 6 squared is going to give me a positive 36. Completed the square. Remembering that I'm going to have to now add 36 to the other side, so I'll just go ahead and write it down. Let's do the same thing for this one. What do? I take half of the 6 and I square it. So half of the 6 is going to be 3. 3 squared would be 9. Y squared plus 6y plus 9. And that's going to equal, and I'm going to have to add, I added 9 here, I'll have to add 9 on this side too. Now I'm going to come up here and do the math with the negative 20 plus 36 plus 9. I end up with, it's equal to 25. You might want a different piece of paper because I know I've not left you enough room to write here. Now let's go ahead and factor our perfect square trinomial here. We know it factors into a binomial squared. We know it has a negative sign. It's x and the perfect square, the square root of the last term, and you can check it and see if it worked, but it does. And we'll do the same thing with our second one. I've got y plus, for this one, 3 squared, and that's equal to 25. So from this, I have gone from the general form of the circle, the equation of the circle, to the standard form. From the standard form, I can tell everything I need to. In other words, I can look at this and pick out h and k. Now, h is going to be the x value of the center, which is 6. K, it would be the normal, remember the equation says y minus the point, right, the coordinate. But since this is positive, it means I have subtracted a negative to get that positive. So this is actually a negative 3. There's the center of my circle. The radius is the square root of 25, or 5. So what would the domain and range be? Well, let's go graph it. I go 6, -3. Here's the center. And I have a radius of 5. 1, 2, 3, 4. Well, I'm off the charts here, but I can figure that out. That's just 11, isn't it? And 1, 2, 3, 4, 5 this way. 1, 2, 3, 4, 5 this way. 1, 2, 3, 4, 5 this way. And I can draw my circle in here if I want to. And I can pick out my domain. My domain is going to start, the smallest it'll be is 1, and it reaches all the way over here to 11. The range goes all the way down to a -8, and then up to a +2. You might want to try this next one, and then come back and turn the tape on and see if you got it. It's basically the same thing. See if you can convert this general form of the equation to the standard form, pick out the center, radius, domain, and range, and then graph your circle. Now I'm going to rearrange it first. I'm going to say my x coordinates would be x squared minus 4x. And then what do I have to do to that? Well, I have to take half of this, which is -2, and square it. So I'm going to be adding 4 here. And then I want to go plus, and I'll do the same thing with y. I have y squared, and I have a +2y. I'm going to take half of that, which is a 1, and square it, which is a 1, and add that. Now, what have I added? I've added a 4 and a 1. So I've basically added 5 to this side, haven't I? What do I have to move over? Well, I'm going to be adding a 4, and I'm going to be adding the other 4 that I just added here, and I'm going to be adding a 1. So really what I'm having over here on this side is going to be 4 plus 4 plus 1, or 9. You can take as many steps as you need to do that, but if you can shortcut it, that's fine too. Let's factor our perfect square trinomial. This one is x minus 2 squared. And this one is y plus 1 squared. And that's equal to 9. So what is the center of my circle? Well, the formula has the negative in it, so it's a +2. Since the formula has a negative in it, and this is a positive, I know that that coordinate is a -1. I have to look at the radius. It's the square root of 9, which is 3. Let's graph that one. I've got 2, -1 right here. Radius of 3 says go 3 in this direction, 3 up, 3 to the left, 3 down, and I can draw in my circle, sort of. And for domain, it goes as far as x of -1, and it goes as far to the right as a +5. Range, the smallest it can be is a -4. The largest is a +2.